I didn't expect company. How are you?
Fine. Oh, I hope you don't mind my waiting here.
No, it's fine. Did you need something, or is this just a friendly call?
First, I got something really great to tell you. Then I want to ask a favor.
Sounds good to me.
My neighbor's kid, Jenny, asked me to help her with her math.
Is that something great?
No. The great thing is, I did it! Can you imagine me helping someone with their math? I was so proud of myself.
And you should be proud of yourself. All you needed was a little help.
What do you mean, a little help? I needed a lot. And I still do, which brings me to the favor. Jenny's working on ratio and proportion.
Well, you should be able to help with that.
Maybe. Frank gave us a proportion problem to study before the next meeting, so it accidentally fit in. I looked up proportion in a book, and I was able to help Jenny because I knew the pattern.
That's good.
The book says proportion problems are solved by cross-multiplication. Now, it works, and that's what I taught Jenny, but I don't understand why it works. Why does cross-multiplication work?
Magic?
Oh, David.
You won't buy that anymore, will you? Well, let's see. Where do I start?
The book talks about ratio and proportion as if they were the same thing. Are they?
They're related, but they're not the same. Ratio, according to a very booky definition, is the process of comparing two numbers by division.
Does that mean that all division problems are ratio problems?
I'd have to give you a very reluctant yes on that. Actually, that's a little bit further down the road. But there is a hidden proportion relationship.
What is ratio, then?
Do you remember when your class talked about families of equivalent fractions?
We worked so many examples I can do them in my sleep.
Well, you have a good basis for ratio, then. Do you remember my favorite example, people in books?
Mm-hmm.
Okay. When I set this up, I always make sure that the books are shared at the same rate or ratio. 2 people for 1 book, 4 people for 2 books, 6 people for 3 books, so forth. Okay, say I have 30 people and 15 books. 30, 15. Now, what's the rate that they go together? Be 2 to 1. Or the ratio is 2 to 1.
Well, ratio is a lot like reducing fractions.
It's almost exactly like reducing fractions, except we say simplify instead of reduce.
Simplify for ratio?
Not all ratios come out even, though.
Uh-huh.
Suppose we have a store with 20 people. 16 of them are women. Now, what's the relationship of the women to the other people in the store?
May I use the chalkboard?
Okay, sure.
16 over 20, that reduces to 4 over 5, 4/5?
That's right, except for one thing. We write it like this. Which means 4 to 5. Which means there's 4 out of every 5 people are women.
Well, that's easy to do. You just take the fraction and put those little dots between the numbers.
Well, these little dots are called a colon. And they mean 4 divided by 5. That's how we express ratio. I think before we go any further, though, you should put the entire fraction family for 4/5 on the board.
4 over 5 equals 8 over 10 equals 12 over 15 equals 16 over 20 equals 20 over 25, right?
Mm-hmm. Now, see how this situation fits the rational family idea?
Aha! Nothing new under the sun, huh?
Nope. Let's try this one. Suppose I asked you to simplify this ratio, 7/8 to 2/3. What would you do?
7/8 to 2/3. Oh, it's not easy to make a rational family out of that one.
That's right. What do you do now?
Divide.
Go to it.
7/8 divided by 2/3 equals 7/8 times 3 over 2 equals 21 over 16.
Very good.
Equals 21 to 16.
Very, very good. Okay, it's time for the second part of the question, proportion. Okay, let's see. I'm riding a bicycle. I pedal 2 times. The wheels go around 3 times. Okay, let me complete this fraction family first. 2/3 equal 4/6 equal 6/9 equal 8/12 equal 10/15 equal 12/18 equal 14/21 equal 16/24 equal 18/27. Okay, say I pedal 16 times. How many times do the wheels go around?
Well, it's right there. 16 pedals to 24 turnings of the wheel.
And this is how proportion and ratio are related. Proportion is comparing two ratios.
Okay.
You got this now?
Yep, I think so.
Okay, there's one more thing about this family. Pick any two members.
How about 2/3 and 16/24?
All right. I want you to cross-multiply the terms.
Okay. 2 times 24 equals 48. 3 times 16 equals 48. Hey, that's odd. They both come out to be 48.
Okay, now I want you to cross-multiply any two other members. Tell me what you see.
Okay. 4 times 9 is 36. 6 times 6 is 36. They all come out the same. No matter what I cross-multiply, they come out even.
So could you say that any time you cross-multiply members of the same family, they always come out equal?
I never noticed that before.
Okay, there's one other thing. Proportion problems are always set up with one term missing. But the one with the term missing is always in the same family as the one with both terms given.
How do you mean?
Okay. 4 is to 5 as something is to 25. Now this missing something is what puts it in the 4/5 family. They are because that's what proportion is. Now since in the same family, by multiplying, by cross-multiplying, we can find the missing number that puts it in the 4/5 family.
Okay, so 4 times 25 equals 100.
Right.
5 times 1n should also equal 100.
Yep.
Then if I divide 100 by 5, I should get the value of 1n.
Right.
20.
Right.
Now, I don't have this cross multiplication just right yet. I mean, I know it works if they're in the same family, but what happens if they're not in the same family?
Okay, try this. 2/3 equal 3/4.
Okay. 2/3, but it doesn't.
Doesn't what?
2/3 doesn't equal 3/4.
How do you know?
I just know.
Can you check it out?
Okay, I'll say 2/3 is equal to 3/4, even though I know it isn't.
Okay, now what?
Cross multiply and find out. 8, 9. See? It doesn't come out even.
But if they were in the same family, they would come out even. So this proves that 2 to 3 is not the same relationship as 3 to 4.
All right. But now how do I use this information?
First, you rewrite what you first put up.
2 over 3 and 3 over 4?
2 over 3 is right, but put 3 over n.
Don't write 4.
3/4 is not part of the family, but 3 over something is part of the family.
What is this something?
Cross-multiply and find out.
3 times 3 equals 9. 2 times 1n equals 2n. 2n equals 9. 1n equals 4 and 1/2.
That's fine, but don't say 1n. Say n.
Oh.
That'll make Frank a lot happier.
Now, I would say, proportionately speaking, that 2 is to 3 as 3 is to 4 and 1/2.
Right. There's just one more thing, and I've got to really run to a meeting. 30 people and 15 books. How many people to 4 books? Remember, the people are always in the same place, and the books in the same place. It's important to keep your order straight.
Thirty times 4 equals 120 equals 15x. X equals 15 into 120. 8. X equals 8. So we get 30 over 15 equals 8 over 4. Got it. Now is that all?
One last thing. In this last example, we know that 120 equals 15x. And that by dividing 120 by 15, we find x. How did we get permission to do that?
Permission?
Think about it. I've got to go.
I know I've taken up a lot of your time, but really, thanks a lot. I hope I wasn't a nuisance.
Hey, you're welcome. I'm glad to do it any time.
Hi, Steve Wise back with you. Let's take a quick review of what Martha and David just discussed regarding ratio and proportion. Ratio is a way of looking at a relationship of two numbers. It compares these numbers by division. Here's an example of ratio and how it would be written as a problem. There were 15 horses in the stable. 5 of them were white. What is the ratio of white horses to all the horses? Now, this ratio would be written as 5/15ths, or 5 to 15, which would then reduce to 1/3, or 1 to 3. 1 out of every 3 horses is white. Remember that the numbers must be expressed in the same sequence as they are stated in the question. Now for a little review of proportion. Proportion is a way of looking at two ratios that are equivalent. Proportion problems asks you to find a missing element in the relationship. This asks, 2 is to 3 as 12 is to what? Proportion problems are solved by a process called cross multiplication. This means to multiply the numerator of one fraction by the denominator of the other. Here are 4 steps to show how cross multiplication is done. First, 4 times 14 is equal to 56. 9 times n is equal to 9n. 9n, therefore, equals 56. 56 divided by 9 is equal to n. Therefore, n equals 6 2/9. This says 4 is to 9 as 6 2/9 is to 14. I hope that helps clear up ratio and proportion somewhat. Now let's get back.
I don't know why I have to learn this stuff anyway. I hate it. And I hate that Mr. Jellison. He thinks math is great.
Boy, I know exactly how you feel. I felt the same way once.
But Martha, it's been a long time since you were my age. You can't possibly remember how bad it is.
Jenny, it hasn't been that long. And besides which, you know, my adult math class makes me feel the same way. Now, what are you working on?
Well, it's fraction, decimal, percent stuff. See, they keep wanting us to go from one thing to the other. They can't make up their minds.
Well, you want to work them together?
Okay. See, it shows this rectangle cut into pieces. And then it says to state the fraction that tells about it. Then it says to change that fraction to a decimal. And then change it to a percent. So you see what I mean? They can't even make up their minds.
Well, do you know where to start?
It has something to do with how many pieces there are in the whole thing.
Good. The number in the whole will give you the name of the fraction.
5. What kind of a name is that?
Jenny, 5 is the denominator, which means name. Now, how many pieces are shaded?
3.
Okay, so 3/5 tells about the shaded portion. How many pieces are unshaded?
2.
So what fraction tells about the unshaded part?
2/5. This is easy.
Well, if it's so easy, let's move on to the next section.
Okay. Now it says express the unshaded portion as a decimal.
Do you know how to do that?
It has something to do with division.
Jenny, you know that when you learn something, you usually like doing it better?
Okay, show me.
All right. 2/5 means a lot of things. First of all, it explains that picture, and secondly, it is the first member of a family of fractions, all of which are equal to each other. So you've got, let me show you, 2/5 equals 4/10 equals 6/15, and so on.
I know, we learned that in 4th grade.
Good, because this is an easy way to make 2/5 into a decimal fraction.
Well, yeah, but I can't do it like that if the teacher wants us to divide.
Well, let me show you how it becomes a decimal fraction first, and then we'll divide, okay?
Okay.
Now, 2/5 is equal to 4 what? 4/10, right?
Yeah.
So that's your decimal fraction. Now look at it expressed as a decimal, okay? On this equivalent chart, we've got 4/10 equals 0.4. Now we'll divide if that's what your teacher wants us to do.
Okay.
2/5. The line means divided by in a fraction. So we go 5 into 2, and I'll put a decimal point here. Even though we don't usually do it, it's always there. And add a 0. So we've got 2 and 0/10. Now I'll put a decimal point there. Now you do the rest.
Okay. 5. It's 4.
For what?
Well, 4/10.
Isn't that what we got before?
Yeah, and the teacher said to divide.
And we did. So now let's go on to the next section.
Okay. Percent. The teacher mentioned something about multiplying.
Yeah, percent is a special kind of fraction. You know, it always has 100 in the denominator. Now, if you were going to take 4/10 and make it into hundredths, what would it be?
4/10, 40 hundredths?
And 40 hundredths equals 40%, because percent means out of 100. See, now that's what your teacher meant by multiplying. If you want to take 4/10 and make it into 40 hundredths, you just multiply by 10.
Oh, okay.
But there is a trick to it.
Mm.
If you have .4, you can move that decimal point over to the right 2 places and swap it for a percent sign, because multiplying it means moving that point over to the right. Now you do the rest of these, and I will do the rest of my dishes.
Okay. Let's see. Oh, wait a minute. Now, this one has a bunch of percents, and it wants you to change them to decimals. What do I do?
Well, let me see.
Can I move the decimal point 2 places to the left?
You can, but watch out for the tricky ones.
Oh, which tricky ones?
Well, take 5%. Express that as a decimal.
Okay. 5% is hundreds, so you move the decimal point 2 places to the left, but there's only one place.
Think about dividing.
What do I do?
Think some more, Jenny.
Okay. 2. Can I put a decimal point here and then put a 0 there?
See what thinking will get for you?
Are there any other toughies?
Well, none that you can't do with what you know already, but let's take a look at this one, 0.2%. Now that's interesting.
You still move to the left, don't you?
Uh-huh.
Okay. 2 places to the left. 0.002?
You got it. Let me get these dishes, okay?
Okay.
There are a few things you should have picked up after seeing this particular scene. First, remember that decimals are fractions with denominators of tens and multiples of 10. Don't forget that percents are fractions with denominators of 100. In order to change a decimal to a percent, move the decimal point 2 places to the right and then place the percent sign to the right of the new number. We change a common fraction directly to a percent by using the following system we saw on Jenny's worksheet. Multiply the fraction by 100 over 1. This will work with any fraction and is a quick way to change a fraction to a percent.
Hi.
Hi, Jean. Excuse me. Hi.
Well, if I had known he was going to be late, I would have done the dishes before I came.
I got my neighbor's kid to help me with mine. She's
Well,
staying with me while her folks are out of town.
Oh, that's nice. Well, you want to get started on this?
Okay.
Well, I guess we're on our own for a while.
Yeah, but you notice he still wants us to work. No rest for you know who.
Speak for yourself.
Hey, where's Frank?
We don't know.
I found out how to work that type of problem.
Yeah, so did I. I wonder if we all came up with the same system.
I looked it up in a book.
So did I.
And I went to see David in his office. He showed me a whole lot of stuff about this process.
Well, now, class, here is a problem we are going to solve. Anyone find out how to work it?
I did, teacher. You have to cross multiply.
Would you like to show us, Martha?
Okay. 7 times 2.5 equals 17.5. 4 times something equals 4s. So 4s equals 17.5. Now, I divide 17.5 by 4. 4 times 4 is 16. 1, 15.3. 3 times 4 is 12. 3, 30. 4 into 30 is 7. 28. 2, 20. 4 and 20 is 5. So S equals 4.375.
Well, that's excellent, Martha. How did you know you were supposed to divide by 4?
Well, if 4 something is 17 and a half, 1 something would be 17 and a half divided by 4.
Okay, right.
You know, David said an odd thing, though. He asked me how I got permission to divide.
That is odd. What do you think he meant?
Well, look, I'll write down the problem again and we'll look at it. Not the whole thing, just the last part.
Okay.
Okay, now, what is next, class?
Well, we know what S is, so let's put that in there.
Okay.
Let's see. Is it true like that?
Yeah, I think so.
Yeah.
Okay, now there's still something missing. What is it?
Well, you said divide the 17.5 by 4, so let's make it a fraction and put that over 4.
Okay.
Yeah, but now the two sides aren't even unless you do the same thing to the other side. And then the 4s on the left cancel
All
out.
right, now here's what's left. From what Martha did with her division, we can tell that 17.5 divided by 4 equals 4.375. They equal each other.
Well, I guess we really did
Yeah.
divide both sides by 4, and that's what David meant.
Well, when you think
Right.
about it, though, we looked at the 4s and wondered what just one of them would be. When in our minds we did divide by 4, so we couldn't have been thinking about one of them.
You know, I remember a rule about that from a long time ago. It said something about, doing the opposite of what the problem said to do.
I kind of remember
right.
that. Maybe we can figure it out from what we already know.
Do we have enough information for that?
Yeah, we can use the last one as our model.
You know, now David always uses N to indicate the unknown, the missing number. You think we should do that?
Well, why not? You know, if N is good enough for him, it's certainly good enough for us. Teach. May I? Thank you. I just felt an urge.
There you go.
Okay, let's start off with something simple, though. How about 3 times N equals 6?
Oh, Bill, David said that when you write 3 times N, all you have to write is 3N.
Okay. How's that?
Yeah, right.
And now we need to make both sides a fraction, so let's divide by 3 on each side. These 3's will cancel out. You get N equals 6 over 3, or N equals 2. Hey, think it
Okay.
works.
You know, I'm beginning to remember how this thing works now. Write the problem 4 plus N equals 12.
Okay.
Now, the backward operation of addition is subtraction. So, if we subtract 4 from each side, that would be N equals 12 minus 4, or 8.
Hey, slow down just a minute. Let's do it step by step, okay?
Okay.
Equals 12 minus 4. So these 4's cancel out. We have N equals 12 minus 4. So N equals 8.
Okay, now, what if the operation on the other side was subtraction?
Well, let's
Well-
see. Let's try it out.
You'd add then to get it to where you could work.
Yeah,
Right.
14 minus N equals 10. You say you would add. So, okay, add 14 to each side. 14 minus N plus 14 equals 10 plus 14. Cancel those out and get N equals 10 plus 14. N equals, now that says that N equals 24.
Wait a minute, that's
right.
not right.
Right.
But what's-
14 minus 24 doesn't equal 10. Something's wrong.
But didn't we do the same thing as we did to the other one?
Yeah, I thought so, but Sue's right. Something is wrong.
Oh, I think I see. Write the problem again.
Well, just erase all of
Yeah,
this.
well, we added the wrong number, and then we didn't even do that right. We need to add N to each side.
Okay.
See if it works that way.
Sure. Add N, so it would be 14 minus N
Plus N.
plus N equals 10 plus N. So this minus and this plus, they would cancel out, and you have 14 equals 8.
Okay.
Did this one of those, did you have to do twice or something?
No, it's still in balance, but we still don't know what N is.
But we know that it's going to be 4, so why don't we subtract 10 from both sides?
That's a good idea. 14 minus 10 equals 10 plus N minus 10. So these would cancel out. You get N equals 14 minus 10. N equals 4.
Okay, that's
right.
Yeah,
All right,
I think
it took
that's
2
got it.
steps then to get it where, with the unknown all by itself.
Right.
Well, maybe you just have to do that sometimes.
Oh, why don't we try one with division in it?
Okay.
What about that?
How about N divided by 4 equals 6?
Okay. N divided by 4. Let's just write this as N over 4, since that's the same thing.
Okay.
Equals 6. What do we do now?
Multiply both sides by 4?
You'd
Okay.
think so, wouldn't you?
Yeah. And over 4 times 4, let's express it as a fraction, equals 6 times 4. Now, these 4's cancel out, so you get n equals 6 times 4, or n equals 24. Hey, perfect.
All right.
We're really getting good at it. But let me see, because 24 divided by 4 really is 6.
Right.
It works.
Okay, now that we have that figured out, what would have happened if we had known the 4?
Okay.
Yeah.
You mean, if I understand you correctly, like this, 24 divided by n equals 6?
Right.
Multiply
Okay.
both sides by n.
All right. 24 over
Gee
n
whiz, huh?
times n over 1 equals 6 n. Now, these cancel out. We get 24 equals 6. Here's another one that you got to do twice, right? Yeah, what's the solution?
Well, why don't you just put the 24 and the 6n over 6, divided by 6?
Yeah, that ought to do it, right. 6, and 6 over here, these cancel out. N equals 24 divided by 6, which is 4, and that's
All
right.
right, there it is.
That's it,
Now, is this the
yeah.
last operation?
Yeah, it looks
I
like
think
it.
so.
But I still
Yeah.
can't, I still wonder why we messed up that one example.
Well, now, wait a second. Let me get this straight. If I see that the signs say subtract, then what I should do to get a different expression is to add on both sides, right?
Right.
And if the signs say add, I subtract. If the signs say multiply, I divide. And if they say divide, I multiply, right?
That appears to be true. Hey, let's take a break till Frank gets here.
Really?
This
I'm
is
gonna
getting
go
like
get a
work.
drink.
You know.
Okay.
Use a drink.
Just as I thought, here I am just a few minutes late.
What do you mean a few minutes late? Frank, you're fired. Not only did we do all your work, but, you know, you
did.
come in at the
What
end of
did
class.
you do? Show me what you did. What did you do?
Well, we started off solving that equation, dividing 17 and a half